Okay, in this problem, we're going to solve what we call bow beam bearings. That's the name of this type of problem, but what we're solving for with bow beam bearings is we're trying to find what the distance off of a light on land or something like that is. Okay, so the way these work is we're going to be giving you relative bearings. So this is the first time that you're going to be seeing these relative bearings. So you'll see the question will say, you sight this light bearing 45 degrees relative off the vessel, and then at this time later, you now sight it at 90 degrees relative. So that's the kind of telltale for this type of problem. And what ends up happening with this problem is you don't even need to plot it. You don't have enough information. The way this works is as we sight these lights, and there's a couple bearings that we're going to use, but primarily we're going to see 4590 and 315 and 270. So when we sight it at 45 degrees relative off our vessel, and then the vessel, as we keep going and we wait until we sight it at 90 degrees now from the vessel, what we've done is we've created a triangle where this leg is the same distance as this leg of the triangle. So the distance traveled ends up being the distance off the light. So all this becomes is a time, speed, distance problem. So you're not even going to try and plot it. As soon as you see the relative bearings, you're solving for time, speed, and distance. So let's take a look at our question here. I'll do questions 1 and 2 just to show you how quick this can be. So the first one says, at 1400, you are making turns for 8 knots. There's our speed. You sight Cape Henry, the Cape Henry light at 45 degrees relative off your bow. At 1430, you sight the Cape Henry light at 90 degrees relative. What is your distance off? Well, our speed is 8 knots. Our time is 30 minutes. So we're going to go speed times time, divided by 60, and we get 4 nautical miles. Not that we actually had to really do a time, speed, distance problem here. We traveled at 8 nautical miles an hour for half an hour, and we end up with 4 nautical miles. So that one was pretty easy. So let's do one more just to show you how we did that. So number 2, at 1800, we're making turns for 15 knots when we sight the Cape Charles light at 45 degrees relative off our bow. At 1823, 23 minutes later, we sight it again at 90 degrees. So using the same formula, using our 60D Street, which we learned in a previous video, we're going to solve this. So we had 15 knots at 23 minutes. So we're going to go 15 knots times 23 divided by 60, and we get 5.75, and that is answer B. That is all we have to do to solve our distance off or our bow beam problems.